Have you ever wondered why Uranus is the only planet that spins on its side? Welcome to a journey into the depths of our solar system, where we'll explore the enigmatic world of Uranus. Uranus, the seventh planet from the Sun, holds a special place in our cosmic neighborhood. It's a gas giant like Jupiter and Saturn, but it's unique in its own right. Its blue-green color, for instance, sets it apart from all the other planets. This hue comes from the methane gas in its atmosphere, which absorbs red light from the sun and reflects back this captivating shade. But its color is just the tip of the cosmic iceberg. Uranus boasts a diameter of about 4 times that of Earth, making it the third largest planet in our solar system. It's nestled in the outer reaches of our solar system, located about 1.8 billion miles from the Sun. That's almost 20 times as far as the distance from the Earth to the Sun. Now let's talk about one of the most intriguing aspects of Uranus: its peculiar tilt. Unlike other planets that spin like tops around their axes, Uranus rolls around the Sun on its side. It's a bit like a bowling ball making its way down the lane. This extreme tilt, a staggering 98 degrees, leads to some pretty bizarre seasons and gives Uranus its iconic sideways spin. So, why does Uranus spin this way? Well, scientists believe that long ago, a body, perhaps as large as Earth, collided with Uranus, causing it to tip over. This event left a lasting mark on the planet, making it the oddball of our solar system that we know and love today. But what about its discovery? How did we come to know about this distant icy giant with its odd spin and stunning hue? So, who was the first to discover this unusual planet? Let's dive into the history. Believe it or not, Uranus was not recognized as a planet until the late 18th century. It's a tale that begins with the curiosity of one man, Sir William Herschel. Herschel, a music teacher by profession, was an avid astronomer who spent his nights scanning the sky with a telescope he built himself. On a clear night in March of 1781, Herschel spotted what he thought was a comet. But this comet behaved strangely. It moved slowly across the sky and didn't possess the characteristic tail of a comet. Intrigued, Herschel continued his observations over several nights, noting its steady, planet-like motion. News of Herschel's discovery spread quickly across Europe. Astronomers were excited about the prospect of a new comet, but some had their doubts. The object's slow and circular path was more characteristic of a planet, not a comet. Among the skeptics was Anders Johann Lexell, a renowned Russian astronomer. Lexell calculated the object's orbit and concluded that it was far too circular and slow-moving to be a comet. It took 2 years of observations and calculations before Herschel's comet was officially recognized as a planet by the astronomical community. This marked the first time a planet had been discovered since ancient times, and the first to be discovered using a telescope. Herschel proposed naming it Georgium Sidus after King George III of England, but the international community settled on Uranus, following the tradition of naming planets after Greek and Roman deities. And so a new member was welcomed into the solar system family. The discovery of Uranus expanded our understanding of the cosmos, proving that the universe was much larger than previously thought. It revealed the existence of a whole new class of planets known as ice giants, and prompted astronomers to search for more planets beyond Saturn. Uranus was the first planet discovered with a telescope, opening up a whole new era of space exploration. Now let's talk about why Uranus spins the way it does. Have you ever wondered why a spinning top wobbles as it slows down? The same principle applies to planets, and Uranus is the granddaddy of all wobblers. It doesn't just spin, it rolls. This peculiar spin is a result of a theory that a massive object, perhaps as large as the Earth, collided with Uranus over 4 billion years ago. Picture this: a cosmic billiards game with stakes so high, it would make even the most seasoned player sweat. The impact was so colossal that it knocked Uranus onto its side. Now, unlike other planets that spin like tops around their axes, Uranus rolls around its orbit. Imagine a ball rolling around a circular track rather than spinning on its axis. And you've got the picture. But what does this mean for Uranus? Well, this tilt leads to extreme seasons on the planet. While most planets have a tilt that causes seasons as they orbit the Sun, Uranus takes this to another level. Its extreme tilt means that its poles, instead of its equator, face the Sun during summer and winter. This results in one side of the planet experiencing 21 years of continuous daylight in the summer, and the other side facing 21 years of darkness in the winter. Just imagine, half a Uranian year, which is equivalent to 84 Earth years, in total darkness or continuous sunlight. It's a concept that's hard to fathom, isn't it? This unique spin also causes the magnetic field of Uranus to be lopsided, making it one of the most complex magnetic fields in the solar system. This peculiarity, caused by the planet's unique spin, continues to puzzle and fascinate scientists. Uranus, with its unique characteristics, serves as a reminder of the incredible diversity and complexity of our solar system. It's a testament to the power of collisions, gravity, and time, creating a planet with a unique spin that continues to captivate us. This unique spin makes Uranus a fascinating subject for astronomers around the world. Uranus is not alone in its journey around the Sun. It has a family of 27 moons. Now, let's delve into the celestial cradle of Uranus, focusing on its 5 major moons named Miranda, Ariel, Umbriel, Titania, and Oberon. The naming of these moons is as poetic as their existence, borrowed from the works of literary legends William Shakespeare and Alexander Pope. Miranda, the smallest of the 5, is an icy world with a peculiar terrain that bears witness to its turbulent past. Its surface is a patchwork of fractured terrains, making it one of the most geologically diverse moons in the solar system. Moving on to Ariel, this moon presents an icy, cratered world, etched with valleys and canyons. Ariel's terrain suggests a complex geological history, characterized by tectonic and cryovolcanic activity. Umbriel, the darkest of the 5, is a mysterious world. Its surface, covered in old, heavily cratered terrain, is marked by a mysterious bright ring feature named Wunda Crater, which stands out in stark contrast against the moon's otherwise dark surface. Titania, the largest moon of Uranus, is a world of deep chasms and high cliffs. The most striking feature of Titania is a gigantic canyon named Messina Chasma, which stretches almost across its entire surface. Finally, Oberon, the second largest moon, is a heavily cratered world with a complex geological history. It is characterized by large impact basins and a network of icy canyons crisscrossing its ancient surface. Each of these moons, with their unique characteristics, not only adds to the beauty and diversity of the universe, but also provides a window into the past, helping us understand the processes that have shaped the solar system. They are silent witnesses to the history of Uranus and the entire solar system. These moons add to the mystique of Uranus, making it a remarkable part of our solar system. So, what does the future hold for our exploration of Uranus? The coming years herald a fascinating era for Uranus exploration. Several space agencies, including NASA, are keen to unveil the mysteries that this icy giant holds. As we look forward, it's clear that Uranus is not just another dot in the cosmic expanse, but a world full of untold stories and scientific potential. To start, let's talk about the interest in studying Uranus's atmosphere. Composed primarily of hydrogen and helium, with a hint of methane that gives it that distinct blue-green hue. This planet's atmosphere is a subject of immense curiosity. Scientists believe it may hold clues about the origins of our solar system and the processes that govern planetary atmospheres. Next, let's turn our gaze to the moons of Uranus. With no less than 27 known moons, each with its unique features, there's no shortage of scientific intrigue here. Future missions aim to study these celestial bodies in greater detail, revealing their geological history and the possibility of conditions suitable for life. And let's not forget the ring system. Yes, you heard it right, Uranus, like its more famous sibling Saturn, has a complex system of rings. These rings are not as visible or as extensive as those of Saturn, but they are equally intriguing. Scientists hope that by studying these rings, they can gain insights into the planet's history and the dynamic processes at work in the outer solar system. While ambitious, these exploratory plans are not without challenges. The sheer distance and harsh conditions make Uranus a tough target. But as technology advances and our understanding of the universe expands, the barriers are slowly but surely being brought down. So as we stand on the brink of a new era in space exploration, the icy giant Uranus beckons. Its mysteries are ours to unravel, its stories ours to tell. As we continue to explore the wonders of our universe, who knows what secrets Uranus might reveal?